When we solve a calculation like 25 plus 17, we immediately understand the meaning of the numbers and perform the addition in our minds. A computer doesn't think this way. Instead, every number and every instruction is converted into tiny electrical signals inside the processor. At the hardware level, the computer only understands two electrical states. A high voltage represents a binary 1. A low voltage represents a binary 0. Millions and even billions of tiny electronic switches rapidly change between these two states. These switches form complex circuits that perform calculations, compare values, and make logical decisions. So while we see 25 plus 17, the computer sees nothing but patterns of electrical signals flowing through microscopic circuits. This is the fundamental difference between human thinking and computer processing. Humans think using meaning and understanding. Computers process information using binary electrical states at incredible speed. At the heart of every computer is a tiny electronic switch called a transistor. Think of it like a light switch. When the transistor is on, electricity can flow through it. This on state is represented by the binary digit 1. When the transistor is off, electricity cannot flow. This off state is represented by the binary digit 0. A single transistor can only store a 1 or a 0, but modern computer processors contain billions of these transistors, all switching on and off, billions of times every second. By combining these tiny ones and zeros, computers can store data, perform calculations, make decisions, and run every application we use. Everything a computer does starts with these simple, binary electrical states. Why do computers use binary instead of the decimal numbers we use every day? The answer is simplicity. Imagine a small ball sitting in one of two stable positions. It can rest on the left or on the right. These two stable positions perfectly represent 0 and 1. Now imagine trying to create 10 different positions for the numbers 0 through 9. The ball would have to balance in many tiny positions. Even the smallest vibration could move it and produce the wrong value. This makes the system much more complex and far less reliable. Using only two stable states makes electronic circuits simple, fast, and extremely dependable. That's why computers use binary. With just zeros and ones, billions of transistors can work together accurately every second to power everything from calculators to smartphones and artificial intelligence. So, how does a computer decide whether a signal is a 1 or a 0? The answer lies in the voltage level. Every electrical signal entering the processor has a specific voltage. Inside the processor, there is a threshold level. If the incoming voltage is above the threshold, the processor interprets it as a binary 1. This is called a high logic state. For example, a voltage of around 3.3 volts is recognized as 1. On the other hand, if the voltage is below the threshold, the processor interprets it as a binary 0. This is known as a low W logic state. A voltage close to 0 volts represents 0. By constantly checking whether signals are above or below the threshold, the processor converts electrical signals into the binary language that every computer understands. This simple method allows billions of transistors to process information accurately and at incredible speed. A single transistor can store only one bit of information. That means it can be either 0 or 1. But one transistor alone cannot represent a letter, an image, or a video. The real power of computers comes from millions and even billions of transistors working together. These transistors are grouped together to form bytes and larger patterns of binary data. Different combinations of zeros and ones represent different types of information. They can represent numbers, letters, program instructions, images, music, and even videos. Every photo you take, every song you play, every website you visit, and every AI response you receive is ultimately stored and processed as massive patterns of binary digits. So while each transistor is incredibly simple, together, billions of them work in perfect synchronization to create the powerful computers and intelligent systems we use every day. From sending a simple text message to streaming a movie, from listening to your favorite music to making a video call across the world, from social media to online shopping, everything we do with modern technology is powered by binary, deep inside every smartphone, computer, and data center. Billions of transistors are constantly switching between 0 and 1, transforming simple electrical signals into text, images, audio, videos, and intelligent applications. Even artificial intelligence, including tools like ChatGPT, works by processing enormous amounts of binary data at incredible speed. It may seem surprising, but every digital innovation we enjoy today is built on one simple idea. Just two states, 0 and 1. Together, they create the complex digital world that connects, informs, and empowers billions of people every single day.